Indirect measurement allows you to use the properties of similar triangles to find measurements that are too big to be measured directly. Trees or buildings, you're not going to be able to go out there with a tape measure and measure them, so we're going to use shadows and proportions to find missing heights. So example number 1 says to find the height of the tree, and they tell us that this person is 6 feet tall and has a shadow of 8 feet, and that the tree has a shadow of 24, but we don't know the height. So when we say that we're using the properties of similar triangles, we're imagining that this is a triangle, and we're going to be comparing the legs of those triangles in a proportion. So we're going to set up the proportion first, and as you know, there are lots of ways to set up proportions that are correct. And I like to write the words in a fraction first as a guide, so I keep both of my fractions in the proportion set up the same. So I'm going to do the height over the shadow. And I'm going to do for the person and for the tree. So the person has a height of 6 and a shadow of 8. And the tree has a height of X we don't know and a shadow of 24. So could you do shadow over height? Sure. Could you do height over height, shadow over shadow? Yes. But it just matters that you're consistent and you set both fractions up the same way. I always do height over shadow, and I just keep it the same way every single time I do a problem, so I don't really have to think about what is right. All right, so now we're going to solve it. And we know that we solve it by doing cross products. I like to do the one with the variable first, so I have 8 times X and then 6 times 24. You can use a calculator as long as you're showing your work as always, and that's 44. And then we're going to divide both sides by 8 to get 18. So the height of the tree, 18 feet. All right, let's try another example. We have example 2 is a telephone pole and a dog, both having a shadow. It says a telephone pole casts a 144-inch shadow. A dog that is 2.5 feet tall casts an 18-inch shadow. How tall is the pole? Do you have to change 2.5 feet to inches? Is a great question. So we know that rates can be used with different units. So let's try it first without changing it. We have the height of the dog is 2.5 feet. The height of the pole, I'm going to do that in a different color. I'm going to say the shadow of the dog is 18 inches, and then height of the pole we don't know, and the shadow in 44. So for the height of the pole, I'm just going to call that X, because we don't know that one. So since the dog is measured in feet, tall, then when we solve this problem, the answer we get for the height of the telephone pole will also be in feet. So that's, we don't have to change our units. If we wanted to know how tall the pole was in inches, we would have to change the dog's height to inches too, but we don't need to do that. Alrighty, let's start proportion here. I'm going to do, as usual, height over shadow. And I'm going to start with the dog. The dog is 2 feet tall, and its shadow is 18 inches. We don't know how tall the pole is, and the shadow is 144 inches. And then I'm just going to use cross products. So first I'm going to do the one that has the variable, 18x. That's going to equal 2.5 times 44. 2.5 times 144 is 360. I'm going to divide that by 18 to get the answer. It should be 20, right? Yeah, 20. That's how tall the pole is, the telephone pole. All right, and then the next example is to go outside with your classmates, and your teacher will tell you which tree to measure. You're going to measure your height and your shadow and the tree shadow and figure out how tall is the tree. And then there is a next section, which is not here on my iPad, where you choose an object outside and do the same thing. So have fun. Okay, done. I'm just making it for today because I'm not. I think I'm planning so far in advance, and I'm like, oh, I changed those notes. I need a new video, but I did it.
Anyways, I just want to say
You're welcome. I'm coming over at 9, yeah, for a little meeting-ish.